I am Irliteracy Syrian, product consultant of Serverless 360, one platform to manage and monitor your Azure serverless applications. Here we have our booth right outside the hall. Please walk in to understand more about our product. Microsoft messaging services have become an integral part of Azure serverless orchestrations, serving over 2 trillion requests per day. We have got sessions lined up for this afternoon with first-hand product updates from the Microsoft team itself. This would indeed enable us build better applications. We are honored to have Dan Rosanova, Group Principal Program Manager at Microsoft. He leads product management for the most powerful messaging services. Dan has got almost 20 years of rich experience in delivering solutions on Microsoft platforms in multiple domains. It includes financial services, insurance banking, telecommunication, and logistic industries, where he has specialized in delivering high volume and low latency distributed applications. I'm sure you all would be interested or looking forward to listen to Dan now. With no further ado, let us put our hands together to welcome Dan Rosanova, providing product update on Event Hubs here at Integrate 2019.
Hello. Is this thing on? Okay. Thanks for having me. Thank you for being here. I hope you can stay awake for an hour because the Ashish is going after me. So at least an hour to get through these things. I am Dan. For those of you that don't know me, this is, I think, my 6th time here. All 5 years that I've been at Microsoft, and at least once before that, where I talked about a different product in the past as a user and as an attendee. So I'm going to give a quick update on where we are with Event Hubs right now and the work we've been doing this year on it, some of which is public and some of which, actually a lot of the stuff at the end of this is not public. So right now, it's probably the most exciting time in messaging, at least in my career, at least in 30 years, because there's actually a lot of choices for messaging today. Up until maybe 10 years ago, all you had was the queue. So everything went through a queue. You might have ETL or something, but the queue just took messages, you went and received messages. The queue was kind of boring, frankly. And now that's changed. Now there are a lot of different messaging platforms. We have 3 different messaging talks here over the next 2 days about Event Hubs for this service bus after me, and then Event Grid tomorrow. And they all do serve a different purpose. We've designed them to coexist together. So it's not like I'm not having some internal fight with myself where we're making multiple products that compete with each other. They're for separate things. And I'll talk about what Event Hubs is for and kind of what we've done to improve it. But real quick, just the fundamentals of a queue, just to keep in mind, because the queue is where we all come from. And I like to tell people, so who here is using Event Hubs today, I guess I would ask. Okay, good. Who is using like a message queuing product like IBM MQ or TIBCO or BizTalk or something like that? Yeah, I would guess quite a few. So this is a different animal. And queues are something we're all kind of familiar with. And the queue is the idea of a server-side cursor. So I send message to the queue. I just go up to the queue and say, give me the next message. And the queue has the cursor. So the server has the cursor. I need no knowledge about it. So it works pretty well in making my job as an application simpler. And it's a competing consumer model, which means that we're all competing for the same resource. All consumers are competing for the same resource. I enjoy speaking in the UK because everyone knows how to queue and knows how to spell it too, which is not the case for Americans. And so the best example of a queue would be something like the turnstile on the tube, right? That's competing consumer. Everyone's trying to jam through the queue. So things like Event Hubs are different. Things like Event Hubs are Apache Kafka. Is anyone familiar with Apache Kafka? Have you heard that yet? If you haven't, you will. All the cool kids are doing it now, I guess. So it's a different concept than a queue. And this is the best way I've seen to explain this concept. Does everyone remember what this was? I think everyone looks old enough to, almost everyone looks old enough to remember this. So this isn't a queue, this is a stream. This thing records a stream. The recording moves forward only. You can play that back over and over again. You know, we used to put data on these things actually, so I'm sure some people still do. So like this is an analogy that I think fits really well for things like Event Hubs or like Kafka that makes it not like a queue. There are some things that are pretty different here. If you look at this cassette, it actually has left and right channels, stereo channels, your headphones. You hear different stuff in each side. And when you record something on this cassette, both of those channels are recording at the same time, but the music that's on them is different. So the data, the information on those channels is different. When you play them back, it actually plays back on different speakers as well, just like the headphones. So in Event Hubs, we call these partitions. We use the same terminology in Kafka as well. So at a more, I don't know if this is more or less Fisher-Price view, looking at like a diagram like this, what you would see is that you've got partitions in something called an Event Hub or a topic, because we messaging people love to reuse terms. So we've used topic like 6 different ways. And the idea is that these partitions are all an append-only log. They're all independent. The data in that partition is independent. So this is a partitioned log. So think about like logging infrastructure you have in your environment. This is like that, but it's distributed and partitioned. There are some aspects that are interesting. The data is all independent. The partitions are all independent. They all run somewhere else usually. And when you're sending data to them, you pick your protocol that you're going to send. For us, we support 3 protocols in Event Hubs, AMQP, HTTP, and the Kafka protocol, the 1.0 version of the Kafka protocol. And by default, we're just going to round robin your data across here. It's going to give you really good availability. It's going to give you really good throughput. That's the default. You can also pin your data to a specific partition. If you're interested about this stuff, I gave a talk at Kafka Summit here 3 weeks ago. Does anyone go to Kafka Summit? It's recorded. You can find it on some search engine, what is it, Google, Bing, something like that, whichever one's running today. Too soon. So when you're reading from an Event Hub, this is what's also different about something like a queue, is this is a client-side cursor, not a server-side cursor. So when you connect to read from this partition log, you need a reader for each partition, and then each reader connects to a specific place in that partition and starts playing the tape forward. So that's an offset. It's a client-side cursor. The client is responsible for that. And there are some aspects of this that are very cool. Unlike a queue, you can have multiple readers, and they read the same data. So the reads are non-destructive. This can actually open up a lot of interesting stuff that's really useful, but it's not a free lunch. I mean, that cursor management thing's not a trivial issue. So like it's not meant to replace a queue. I'll get to that in a little bit. So some cool things that we do with Event Hubs. It's a real PaaS service. It's like storage, like blob service. There's no VM to manage. You don't SSH or RDP into anything. There's no software to patch. It is always SSL and TLS. All of our messaging services are, and all of our messaging services are PaaS actually as well. Has IP filtering and VNet because people kind of like security, it seems. It's got AAD, managed identity. Everything in Azure is going to get managed identity. If you're not using managed identity now, you will be soon. This is the idea that you can grant VMs or services access to resources without passing keys around. Then Active Directory does the authorization and authentication for you. And speaking of authorization, actually, it's got RBAC. Everything in Azure is getting that as well. Event Hubs has auto-inflate. The best analogy, besides the tape, I guess, for something like a stream is a hose, a garden hose. There's water running through the hose. So the pressure is how much water is running through, how much data is running through. And this service has a way to actually scale up. We measure it in megabytes, basically, and just scale up as your traffic increases. We call that auto-inflate. And it's got metrics for just about everything you want to see. So metrics on a per partition basis of traffic going in and out and on the consumer groups and stuff. And real briefly on the previous thing, the consumer groups thing, some people call this architecture pub sub because they think that because you can read more than once, it's pub sub. I've been in messaging 21 years now, and I would not call it pub sub. I think it's something different. It's powerful and it's cool, but it's not pub sub. And then we have GODR in the service as well today as well. So not too many services have this yet. I would guess all of our services will have it over time. This is user-controlled RTO, so recovery time objective. That tends to be something people in your shoes sort of want. I did when I had a real job, so it was one of the first things we added to this. And then finally, a feature, the only kind of feature thing I'm going to talk before I start talking about availability stuff, is capture. Not too many people are using Event Hubs. Is anyone using Event Hubs capture feature right now? Cool, a couple people, good. Not enough people, I'll tell you why in a second. Capture, what's funny about Event Hubs is we worked very hard to make a real-time system that would be sub-second end-to-end latency, durable, reliable, all this stuff. And what we quickly learned was that people want to do batch processing. When I was working with that other integration server, that's name I'm not going to say, that a lot of you use, then I tried to convince the world to go to real-time messaging for everything. And I've given up on that. The world will never go real-time. Some things will be real-time. A lot of things will be batch. My last paycheck will be a batch. My death certificate will be a batch, probably on a mainframe, no matter how long I live. So what we did with Capture is give you batch on the real-time stream. So this is a policy-based control. It uses an Avro format, Apache Avro, if anyone's familiar with that. It's kind of popular with all the big data tools. It's fully integrated into the rest of Azure, so it raises event grid events when this capture operation happens, so you can trigger functions, logic apps, whatever you want. It doesn't impact the throughput, so this doesn't count as another reader reading from your stream, which if you look at some of our more advanced talks we've given on Event Hubs, kind of network imbalance is a thing you need to be aware of. And it lets you offload your batch processing from your real-time stream. Everything fast is expensive, right? If you're building a house and you want it done very quickly, it's going to be more expensive than if you do it more slowly. If you drive your car very quickly, it's going to burn more gas. Messaging is the same way. So real-time is expensive. It's great if you can do it. It's great if you need it. But if you don't need it, you can save a lot of money by batching. And this is how Capture works. You see your old friend, the Event Hub. It's got its partitions. There's some data in those. You give us a storage count. It's your storage count, either blob storage or ADLS. You give us a time and size window. That's the policy control. And whichever of those windows crosses first will create files that have your stream of data per partition in them. Then you can go run whatever you want on those. Setting this up is fairly easy. You can see this is the whole thing. There's two sliders, minutes and megabytes. You pick your storage provider. And then importantly, we have done some work this last year that you might know about already, including giving you the option to not create files when one of those windows happens. The idea is it's a window. It's going to be minutes or megabytes, and we're always going to close the window. Some people didn't like that they close the window at night when there's no data, but now it's an option. And like I mentioned, it's integrated into the rest of Azure, so you can use Grid for all this stuff. It's pretty useful. Today, very easy to use with logic apps. Functions is getting a little easier as well. And the idea here is that this is really well integrated into the serverless story. If you're trying to flow information across your organization, you're going to get people, especially when I get to the Kafka stuff, you will get people in the future coming to you with Kafka. And you'll want to move that data around. You'll want to use it for application purposes. You'll want to use this in as simple of ways you can. And so today, it's very easy to use Capture with functions, with logic apps, with container instances. And the nice thing here is you're getting one instance of that function per file. So you get automatic retry in Grid. That like we're using the other parts of the platform to make this easier, but you're also getting automatic scale. And the nice thing about that is if you noticed I had a 20 megabyte, 5-minute window, if I start sending more data, then it's not going to be the minutes that hits, it's going to be the megabytes. And as that happens, I'm going to get more files created. Those more files execute more functions in parallel. And so it actually scales in place for me. And I don't have to do anything. And auto-inflate works with this as well. So if you've enabled auto-inflate, which is a different policy thing, we love the policy stuff in my team. It's a policy to let you decide how high you want to scale. And we'll just bump up your scale as you hit the limits. So my first question to everyone here would be, why aren't you using this? I think about 20% of customers are using this right now, and the work we did to investigate this before we built it said that about 80% should be. I think it's just people don't really see that it's there. So we're going to move up the icon a little higher on the portal to see if that helps. So what would you use this for? You'd use it really two kind of primary purposes. One is to have a golden copy. You want to keep some data forever. You want to keep it in cheap storage, so you can use policy on storage as well to do like cool storage or cold storage. And you might want to reuse your existing batch processing tools. So win-win there. Cool. I already asked this about who knows about Apache Kafka. Actually, a little bit surprised more people don't know. The conference here was pretty cool. And when I was here, I was arguing about how Kafka is not a queue. And the Apache Kafka people themselves agree with that. They put this on Twitter, which it's not a queue. So it should be obvious now that this works a little bit differently. Kafka is an interesting animal because you're going to see it come up more and more for things like this, change data capture. Is anyone here using a change data capture software of some sort? Maybe like Oracle Golden Gate or Attunity or HVR. Like these things use Kafka internally as a transport mechanism. So you won't really see them, but people will say, oh, if you want to use this, you need that. A lot of telemetry stuff already uses it. Splunk's integrated with Kafka. IBM QRadar is integrated with Kafka. Azure's messaging stack is now integrated with Kafka because of Event Hubs. And anyone building applications on the event sourcing pattern. Actually, event sourcing used to be popular, even in this, actually it was very popular in this city, maybe 15 years ago. But when we only had queues, it was a hard pattern to pull off. So it's coming back now. And then sort of big data pipelines. So feeding big data pipelines is another canonical use case for this. We offer Kafka in 4 different ways in Azure. There's kind of DIY, do it yourself with IaaS. There's a marketplace offering. There's quite a few actually, including Confluence. They're a big open source company behind a lot of Kafka. There's cluster option through HD Insight. This is a cluster that you get. It's your cluster. It's compute. You can SSH into the nodes. You're kind of responsible for tuning and maintaining it, but it's very easy. You can add nodes without having to mess with the network. And then finally, there's Event Hubs, which is our PaaS service for doing Kafka. So setting up Kafka, if you're not using a PaaS service, has a little bit of work. You need to prepare servers. You need to be prepared with the VMs for them. If you're using virtualization, configure your network both physically and virtually. Install and configure Zookeeper. If you're running big data stuff anywhere, you're probably playing with Zookeeper already. It's loads of fun. And you need to install and configure the messaging brokers themselves, and then install and configure SSL, which is the easiest thing in the world, right? Now I will walk you through what it's like to enable Kafka on Event Hubs. Please bear with me. This is a little bit technical. You click this button. And what we've done then is we've actually, yes, how did we make this magic work? We're not actually hosting Apache Kafka. We decided against that, and I'll get to that in a second. But 2 or so years ago, the Apache community, the Apache Kafka community, decided that they would document the protocol that's used by their software. And this is kind of a new thing. Usually people do standards, protocol standards, like AMQP, which we're heavily involved with at Microsoft, but there's not really a reference implementation to go with it. What's cool about this is there is a reference implementation, and now there's a protocol standard which defines that it will have backwards compatibility. And we saw this as the green light for us to get into this game, because now we can start offering things that Kafka gives you, but not be kind of tightly coupled to the implementation choices that they've made, which are choices that we're not always pleased with and that are evolving over time. And I'll talk about those in a second. So this is what we offer for our Kafka service. What it really is the APIs around this. So we're actually running Event Hubs. We're not running Kafka. We're running compatible, wire-compatible APIs that work with Kafka clients. So when you enable a Kafka on an Event Hub, you use the Java or Python or Node or whatever client you want for Kafka, not a Microsoft library. Use that library, and it works at a binary level on the network. How we started all of this was back in the way back machine, not quite as far back as that guy, I guess, but close, in tech terms at least. We had to think about, do we want to host Kafka or do we want to try something else? We split the team in 2, and they competed with each other to see what would be the right answer. I can't take credit for that. It was 6 months before I joined. And what it came out to is that at the time in 2013, Apache Kafka was very immature, and we decided not to use it. We chose what we did because we needed something that would be cloud native. Cloud native is very different than running in a bare metal data center, which is what Kafka is still designed to do today. We needed something that would be multi-tenant because of we are a cloud provider, right? It has to be multi-tenant. And we needed something that could guarantee 0 message loss. And at the time, Kafka couldn't do that. Kafka has improved this, but the first 2 were still problematic in Kafka. So we did some things that were a little bit different. We're actually utilizing external storage, so we don't store your data on our brokers. We store it in page blobs, just like you could if you were using Azure. So we use VMs and page blobs. It's not really that complex. We do a lot of sophisticated caching. This really gives us we're not just a pass-through to storage. What I mean by that is that we're actually getting a ratio of about 300 writes per read. So since it's a real-time stream, if you're reading in real time, we're getting really good cache hit ratios, and we read ahead. And we prevent dirty reads and all the stuff you would expect. Importantly, all the messaging services in Azure do this. We triple replicate before we ACK back. So if you send us data, we'll never tell you we got it if we haven't already triple replicated it. You'll see people with Kafka and sometimes things like RabbitMQ say how fast it can go and all this other stuff. Oh, my one laptop can do 800,000 messages a second. Yeah, in memory. Like if it crashes, I lose 800,000 a second. So these are the kind of decisions you have to make here. In the Kafka world, if you're familiar with it, what we're doing would be the equivalent of in-sync replicas, ISR equal to 3, and acknowledgements equal to all. And we're built internally on Service Fabric, which gives us a kind of orchestrator model we like better. And we have a 2-role architecture, meaning we have a communication gateway that hosts our protocols, like the Kafka protocol, and we have a backend that actually coordinates the storage. I'm running a little short on time, so I might skip through some of this. Dedicated capacity is a single tenant offering that we have for this. If you're using Kafka, you're probably doing hundreds of megabytes a second. We sell Event Hubs for people that, yeah, they can do 100 megabytes, gigabytes, whatever, but a lot of people just do 1 or 2 megabytes per second. A lot of people don't need a huge stream of data, so they use our multi-tenant platform. We have a single tenant instance of this. It's a PaaS service. It's the same PaaS service. It's just for only you, and you pay for just the hours on it. And the smallest size we sell is about 100 megabytes per second. We'll do somewhere between 100 and 250 megabytes per second, and we'll sell you 20 of those together in one giant cluster. So it gets a little costly at times, but for gigabytes per second, you're always going to pay a lot of money. So it's the easiest service to use out there. I was actually going to demo. Let's see if this actually works. No, I'm going to skip it. I'm running a little short on time, so I was going to demo the new portal for this. We're shipping the portal experience to create this in a couple days. So if I have time, I'll come back, and you'll be the first people outside of Microsoft to see it. So one of these stats actually came up earlier. These are just stats about our traffic for just the Event Hub service. It's actually up to about 2.2 trillion requests a day. People are capturing about 2 petabytes a month of data, and we're running the service at about 5 nines, almost 6 nines of availability on a weekly basis. And yeah, pretty good stats, but this is the one I want to focus on, this availability. So what are we doing with this availability? This actually sounds pretty good, right? Almost 6 nines? Sound good? Yeah? Okay. Yeah, maybe. Except with 2.2 trillion requests and having that much availability, there's still 4.4 million failures a day. And if that's your data, you're not going to be very happy about it. So we'll tell you it's a failure. It's not like we lost any messages. Let me be clear about that. We just didn't acknowledge. So you the clients will try again. We knacked or didn't respond. So we've been working on improving this, and this is why we haven't been shipping a lot of features the last 6 months publicly. So I'm going to tell you about all the work we've done here for the next 10 minutes. Our clusters kind of look like this. We've got some servers. It's more than 4, but I'm just trying to illustrate a point here. You create a namespace. We create containers. Again, tech people love to reuse that term. This is not a Docker container. It's a Service Fabric container. And the containers host your partitions. And I'd like to dispel a myth here for anyone using Event Hubs. Creating more partitions isn't going to make your Event Hub faster. We put it on the same 4 partitions or 4 containers. So you'll make each partition slower if you create more. We then go distribute those containers on our clusters, and as other customers come up, we distribute their workloads as well. So they're all spread around our servers. We usually have lots of customers on a cluster. Clusters are very, very big. When one of those servers fails, we use Service Fabric to move those containers to other nodes. So it's then during this failure point that something is happening, that we're having a blip in our service. Can anyone tell me what is the significance of this number? And I didn't pick 42, so. 21 is the default TCP retry window. Exponential backoff in TCP, and this is the same for Windows as it is for Linux, is that all requests can be retried 2 times. The default value for the retry window is 3 seconds. So 21 is 3 plus 6 plus 12. So basically, it takes you 21 seconds to know that a socket that you're talking to on the other side is dead. So when you're doing tens of thousands of messages a second, 21 seconds is a long time, and you're just kind of dead. And it's the same for when sockets drop or is when you're connecting to new sockets. So when might this happen? When might a socket go dead? This is a time when this might happen. Anyone ever have a server reboot on you? Yeah? Anyone ever have a server in Azure reboot on you? Yes, it happens. Amazingly, though, Azure has an answer, but a lot of people just don't know about it. We have this Azure metadata service, and it supports something called schedule events for Windows VMs. We implemented this for us earlier this year. If you're using Service Fabric, it's very easy. If you're not, it's also possible and fairly easy. What this is that the VM system in Azure will give you notifications about maintenance events that need to happen. So it's giving you time to prepare that there's going to be a change in your infrastructure, like a reboot is coming. And then your software and the Azure software, the Azure VM software, can do a dance to decide when to reboot which machines in an orderly fashion so that you can avoid the 21-second window. And what we do is we use these notifications to start draining the brokers that need to reboot in the right time, moving the workloads over, and instead of having a 21-second window, we now have like a 1-second window. So we've increased our availability that way a lot. This is available for virtual machines in both PaaS and IaaS in Azure, so you should be looking at it. It works for Windows and Linux. If you're not using this yet, you should be if you're using VMs. Here's an actual example for one of the IoT Hub clusters of when we first started using this. This cluster averages about 4.5 or 5 million requests per minute. You can see here that it's rolling through the reboots for all of these. You can also see how even the reboots are. This is Azure rebooting underneath us. It's not our service doing maintenance. It's the VMs having reboot, which there's a lot of reasons that VMs have to do this in the cloud, and every cloud provider makes you go through this. It has to do with things that we're not just hosting. You're not just getting bare metal from us. This is all software-defined network. It's all distributed. And over time, things drift, and we need to reconfigure stuff, so we have to reboot a VM. So this upgrade started on March 16th at 23:10, so 11:30 p.m. It completed on the 17th, on St. Patrick's Day at 1:30. Barely remember what I was doing then. During that time, at 4.5 million requests a minute, we had about 607 million requests. Actually, we had exactly 607,056,540. Of that, 1,997 of them failed out of 600 million. So during an infrastructure upgrade that we didn't have direct control over, it wasn't our infrastructure, it was Azure's infrastructure, we had 5 nines of availability through this. So you can get that too. This is already available for you now. And you should be looking at this. We're still tuning it, but you can use this. This is during a platform upgrade. There's actually more that we've done than besides just this. I wanted to use a picture of Billy May, but that's copyrighted and I can't. People here might not know who he is, one of the TV sales guys. So our clusters look more like this. And actually there's a lot more colors on them because there's thousands of customers, not just a few. And we have thousands of namespaces. Some of them are very busy. Some people do a ton of data, 20, 50, 100 megabytes a second. Some people do very little. It changes throughout the day. And again, when you come create a namespace, we have to find a place in our clusters to place it. So there's lots of dynamic creation and deletion going on here. And we have to move the same way we move traffic around for reboot. We have to move traffic around as the load changes on the clusters throughout the day. So we made some load balancing improvements that were significant. In the past, we tried a lot of different metrics to do this. The number of containers on a server, the CPU utilization, the memory utilization, and the throughput on that server. And what we found is that each container move obviously caused a very little blip. And we found that trying to perfectly balance the load never works. So we end up in this weird place where these two can never be perfectly balanced, right? So our service would fight itself. And yeah, we'd get that 5 nines or whatever, but there'd always be internal fighting happening. What we ended up realizing that relaxing the rules actually improved our availability a lot. So we deployed this about 6 weeks ago. Here's an example of another production cluster used by an internal Microsoft team. They do monitoring and testing of other Microsoft teams, basically. In a 24-hour window, their cluster had 25 billion requests before we turned this on. About 120,000 of them failed. That's not bad. It's, again, 5 nines and a 5. That's okay. After we rolled out this load balancing improvement, the very first day it was rolled out, they did 21 billion requests. So it was just a few less requests that day, less busy, and 11 of them failed. That is, I will save you the trouble of counting 9 nines of availability in a 24-hour period. You can guess where we turned it on, looking at this chart. So this is a chart of the load of the container count on each broker in our cluster, and you can see where this came into effect. So I don't think you're really going to do much better than that with anything running on Zookeeper, and probably not running anything not in Azure, frankly. We're getting pretty good with this. Our whole service now is running at about 7 nines availability, and we're trying to actually ratchet that up. I told the engineering manager, what comes after 9 nines? 100. So we'll see. In summary, kind of things I want to leave you with are that especially as this whole Kafka stuff comes forward, when you're looking at these streaming applications and the infrastructure you're going to need to run them, there's no scale that you're going to need that we can't do. We have customers doing gigabytes per second on a single event hub, or single topic, you would call it in Kafka. So we can meet whatever scale you need. It is already the most available messaging service in the cloud. Part of that is because the way it's a partition consumer just means that we naturally get higher availability, whereas in a queue, if you need someone to be an arbiter of order or something like that, you take dependencies on having lower availability. It is extremely affordable. You can send 1 billion requests a day, a terabyte of data for $37 US with that kind of availability, with 9 nines of availability. We don't warranty the 9, but we warranty 4 on dedicated. So it already powers a lot of our stuff in the cloud. Try it out. I think you'll be pretty happy with it. Try out Capture if you're not using it yet, and try out Dedicated if you have the chance. It should be live in the portal in a week or two. It looks kind of cool. I wish I had time to show it to you. I don't think I will, though. And in that, I'll take any questions that people have in the 2 or so minutes. We can always run over Ashish's time. So, any questions about Event Hubs? Anyone going to go use it? Yeah.
So I would like to ask that. So you mentioned that Splunk is using or going to use Kafka. So we are a big customer for Splunk. So but the question is that the vast majority of our security solutions they generate files.
Yes.
Yeah.
Yep.
So therefore we would like to do streaming, but the question is, does that make sense to ingest the files and put it in Event Hubs?
I'm glad you asked this. The question is basically about things like Splunk tend to use files. A lot of stuff integrating with Splunk use files, and that these streams aren't files. So should you force the files through the stream? No, I wouldn't. Splunk will interface with Kafka. It's not going to be written on Kafka. Maybe. So that's their business, not mine. Don't put big files into Kafka. It's just like putting big files in the message box in BizTalk. Damn it, I was not going to say that name. I made it 29 and a half minutes without saying that name. Same with like a message queue or something. You put a big file in it, it breaks stuff, or it slows it down. Do like a claim check pattern if you have to, or the reality is some things will never be real time, and a file is fine. Just ETL. ETL's worked great for a long time. Just keep doing ETL. Nothing wrong with that. Thank you for asking that.
Yeah. Because it's a kind of conceptual question, right? So whether I do that or not.
Yeah, don't let perfect be the enemy of good. Like it's not. It doesn't go well. I've tried that. Anything else? All right. With that, I will turn it over to Ashish. Thank you.
Covey.co